So today's lesson is about another homologous series called the alcohols. Alright, so the alcohols are the one that you find in alcoholic drinks, in solvents, in your makeup. A lot of places contain alcohols. And what make them alcohols is because they contain the functional group hydroxy. Okay, the hydroxy group is a OH group like this. And you need to be able to draw and name the first 4 alcohols in a homologous series, give the structural formula and the molecular formula. So let's pause the video now and try to recall how do you draw all of this. Okay, so I'll see you after the pause. Okay, so I hope you are able to draw the full structural formula, write out the structural formula like this, right, as well as come out with the molecular formula. Remember my expensive Prada bag, anol. Okay, and as what I have mentioned in the alkanes and the alkenes lesson, the general formula doesn't need to be memorized. What you need to do is to look at this structural formula over here, right? What is happening over here? So you can think of a possible general formula. So we have CH3OH, we have C2H5OH, then after that we have C3H7OH. So do you see any patterns? Right? So you might notice that it is a CN H2N plus 1. Okay, CN H2N plus 1 OH. So this is something that you can derive by yourself. Okay, so what is the properties of the alcohols? So let's look at the properties. So properties of the alcohols is because they contain the hydroxy group. Now, however, this shouldn't be confused with hydroxide. Hydroxide is an ion, hydroxy is a functional group. And alcohols are neutral and they are not basic. Okay? However, alcohols are actually soluble, right? And the solubility decreases as the molecular size increase. So as it becomes bigger and bigger, it becomes less soluble. However, when it's soluble, it does not form ions. It's a non-electrolyte. Does not form mobile ions. Okay, first 4 alcohols, they're all liquids, not like gases, and they are definitely flammable. So alcohols, they are formed in 2 methods. The first method is the one that we are very familiar with. We will form from the ethene, right? Adding with steam, with your concentrated phosphoric acid, with your 60 atm and your 300 degrees Celsius to form your ethanol. So how does that look like? You have your ethene. This is from the alkene side. With your water, I like to draw it like that. So you can see that this part adds in here, and then this part adds in here. So then I will form an alcohol. Remember to check that the carbon only has 4 bonds each. Okay, so as what I said, this part attaches it here, so you get this, and then this part attach here, and you get this. Okay, alright, so this is the industrial method to produce most of the ethanol in the world. However, when we want to drink the ethanol, that means we want to use the ethanol for consumption, we have to use this process of fermentation. Fermentation is you're putting some things together and let it decompose, rot. So what do we do is that we ferment a glucose solution. And this glucose solution is where all the alcoholic drinks get its taste. So like for example, wine, the glucose comes from grapes, right? And then maybe like beer, you get the glucose from malt, right? So this glucose solution, you leave it by itself, it wouldn't ferment. It will actually, you need yeast. And yeast is a living thing that will cause the fermentation of glucose. But this yeast doesn't ferment at any temperature. It must ferment at around body temperature, 37 degrees, and there must be no oxygen. So we must prevent oxygen from interacting. That's why you see in fermentation there is this like fermentation flask, and then there's an airlock. We use something to block the air from going back in. So then the product form would be actually the ethanol, right? And you will also produce a lot of carbon dioxide gas. So how do I write this formula? So over here, we have the glucose solution. This is very important to put that it's a solution, and then it will require yeast. It will require 37 degrees Celsius and no oxygen. And you will form ethanol, which is C2H5OH plus carbon dioxide. You balance it out nicely, that will be a 2 at the front over here. So I repeat, glucose solution with yeast, making sure that's around room temperature with no oxygen, and then you will form ethanol and carbon dioxide. Okay? So over here, there's actually some very interesting parts to this reaction. The alcohol formed from this chemical reaction has a maximum of about 15% alcohol. Okay? The reason why it forms only 15% alcohol is because when it's more than 15% alcohol, the yeast will die. So what would people who make alcoholic drinks do is that they'll make 15% alcohol. Then what they do is that they take this mixture and they'll go through distillation, right? They get distillation to get purer alcohols. So your distilled alcohol is made this way. Okay, so this 15% is something that you need to take note of as well. Alright, that's great. So now let's look at some of the reactions of alcohols. So we all know that organic compounds will do combustion. So combustion of alcohol. So let's use ethanol, methanol, CH3OH. And then when we combust, react with oxygen and heat, I'll get carbon dioxide plus water. And then if I balance this, I believe it would be something like, wow, this is a tough one to balance. I think this is 2, and then that will be 8, 4, wow, 2 carbons, 8 hydrogens. Now I have 8 oxygen minus 2, so 3. Okay? Okay, now it is very important, the next one, that we must understand that alcohols would form carboxylic acid. Right? So let's just try. So we don't need to memorize this too much. We just need to know that alcohols become carboxylic acid. So let's try with ethanol. So we know that ethanol will become ethanoic acid. So what we do, we draw it. Okay, so ethanol we know is et, so there's 2 carbons. And then anol means there's a hydroxyl group. And then I fill the rest up. Right, and then ethanoic acid, 2 carbons again, and carboxyl group, so double bond O. Remember not to add an additional carbon, and then fill the rest up. So this is an oxidation reaction, and then it will work with oxygen in the air, and you need to have a little bit of bacteria. Okay, so the oxygen, you don't really need to balance, it will just go in to form an oxidized product. Now, this oxidation can happen in the lab also. So the same process, you have your ethanol, and then in your ethanol, you will react with our favorite potassium permanganate, manganate 7, KMnO4, to form our ethanoic acid. So same reaction, slightly different reagent, but same product. Okay, so I believe over here, not only will we form the ethanol, we will also actually form water. So on both of these, we will have H2O, and H2O. What is important for us to remember is that this KMnO4, it will turn from purple to colorless. So let me just recap the chemical reactions. So firstly, we must know how to produce ethanol, either the industrial method or the fermentation method, which I need to know the steps. Then you must know that alcohols go through combustion, right? And then you also need to know that alcohols can become carboxylic acids using oxygen or oxidizing agent, KMnO4, to form a carboxylic acid and water. Alright, so that is alcohols, and hope that will be okay for you. Practice, all the best. 3, 2, 1.